Next up, going to hear from Stephen Laine, who's got some more insight from the simulation side of the equation. Stephen, take it away.
Perfect. Thanks, Dan. Do you see my screen now?
Yes, we do.
Perfect.
You meant to share your Spotify playlist? Yes. Just kidding. Yes, we can see. You can see your slides.
Yes. Nice, good. All right. So yeah, I'm going to take you through how we're helping to transform simulation workflows with AI agents and physics AI. This is really going to build on a lot of what the other speakers have been saying, what Synera are doing as well. There's a lot of synergies there. So what does SimScale do as a very quick introduction? Well, SimScale helps engineering teams to innovate faster. And we're doing this by helping engineers to explore thousands of design decisions in seconds. And I'm going to show you how that's possible. There's about 700,000 users of SimScale worldwide and being used quite extensively throughout the globe. I'm not going to spend too much time on this. Let's get to the meat of it. So, as others have mentioned, there's a significant gap between engineering AI expectation and reality. So we surveyed 300 leaders recently, and 93% of engineering leaders expect productivity gains from AI. However, in the survey, we found that only 3% are achieving a very high impact from actually implementing AI. AI adoption is definitely still in its infancy in engineering, but cloud native users are 3x more likely to have mature AI programs and 6x more likely to have the clean, centralized data source that they need to be able to leverage AI effectively. Siloed data and legacy tools remain the two biggest barriers to AI adoption, especially with on-premise CAE users. So, this goes back to the idea that that data isn't accessible, it's siloed, can't necessarily be used for AI. And something that we're hearing generally in the industry is that there's a need for speed. So in the transportation industry, we're typically seeing that transport companies are being pushed to respond much faster in the supply chain to RFPs, where maybe they used to have 4 months. They're now lucky if they have 4 weeks of time to respond to an RFP, and they need to do a lot of the technical work in the response. So, this really goes back to the example that Moritz demonstrated as well. The electronics industry need to release 2x more products per year than they did 5 years ago to keep up with the competition and maintain growth. And in general industry, they need to transform their product portfolio while maintaining margins. And in medical, it's the first one to market that wins. So all of these need faster innovation. And this is why we're seeing a need for speed. So the traditional workflows create a bottleneck here. There's a simulation lead time. So imagine an organization receives an RFP. They then start technical work and generate a design concept. That design concept gets passed to the simulation expert to start simulation work, and there's a delay time there. They make some recommendation, there's a new design iteration, and maybe a final simulation validation. In a certain space of time, you only have time for maybe 1 or 2 design iterations with this traditional process, because there's a lot of waiting happening, just like Moritz was saying. So you may issue your proposal just in time. Now, if we look at the approach that we can implement, if we accelerate this with physics AI, then we can do many more iterations in the process, because we're putting inference in the hands of the designers so that they don't have to hand off to a simulation expert. They can either run full simulation, or they can iterate even faster and do thousands of iterations if they use inference. So the inference enables these very rapid predictions of results, and they can iterate through many, many more designs in a given time. So that's, in SimScale, what we're calling physics AI, and that's accelerating the simulation process. And physics AI is nothing new. There's many companies implementing physics AI. What's a bit newer, and we're in the age of agentic automation, is the engineering AI side of things. So the multi-agent workflows, the automation of that whole process. And with engineering AI, you can really work over the whole process, look at the RFPs that are coming in, use LLMs to understand those RFPs, start to compare data that you've built up in a library over time of different RFPs that have been responded to, start to build some engineering ideas and start to do inference against physics AI models that you have. Where the physics AI models aren't available, you run full simulations and then feed that data back in to the physics AI model. So we're really seeing the need to implement these full engineering AI workflows now. So let's focus a bit more on engineering AI for a moment. With engineering AI in SimScale, it's very similar to what Moritz was explaining in Synera. Where does the data actually come from? Well, we're using LLMs. So there's no need to do direct training. The agent in SimScale comes ready out of the box to work, to understand simulations, to understand high-level questions, and help with the setup. You can augment the agent with your engineering data, so you can provide past examples of simulations, you can provide standard operating procedures, documentation from the PLM system, etc., so that it has additional context, but that isn't necessarily required. It already understands out of the box how to run a simulation. So then obviously that can enable many other workflows to be triggered just by running the agent and being able to use physics AI in the background to do inference, etc. So in SimScale, we're doing all of this in the cloud, obviously, and we believe quite strongly that only a cloud-native platform can deliver a full end-to-end simulation, physics AI, and engineering AI solution. With SimScale, everything is on the cloud, so it's very easy to access, create training data, publish models, and work in the cloud. There's broad physics capabilities, everything's scalable, and it's a collaborative platform. So you can deploy anything that you create, physics AI or engineering AI, very broadly. You can automate workflows and essentially accelerate the design so that you can do many more iterations in a given time period. So that's a super quick overview. I don't want to spend too long on that because I want to get into the actual platform now and show you how this works. So I've got a structural analysis of a robotic gripper assembly here where we've performed a static structural analysis. And imagine that I'm an engineer now and I'm coming in to pick up the work here. So I can use the agent directly in the platform here. So I can speak with the agent and say, hi, I need to run a frequency analysis. So the agent here is able to talk with us, help us through the simulation setup. This is an example of a simulation specialist agent. Now, the agent that we're using here is completely out of the box. I haven't provided any additional context. So this is exactly what you get in the vanilla implementation. So you can see here that the agent has set up a frequency analysis. We can see in the tree structure, it's created that here for us. And it's asking if we want it to proceed with the setup. So yes, let's go ahead. Set up the analysis, assign aluminium to all parts, and fix it at the saved selection. And it's fixed. So it can give some basic instructions of how it can do the setup. Now, we have to give quite a bit of instruction at this stage because it's obviously out of the box solution. It doesn't have much additional context. It doesn't know maybe that we always save the saved selection as a face name where it needs to be fixed. It doesn't know what materials we normally use, but all of those things could be provided as standard additional context. So now I'm completely hands-off, and the agent will go through and do these setup stages for us. Obviously, the really powerful thing here is this could be run completely in the background. So this could be part of a agentic workflow that's triggered from another tool. It could be run from a tool such as Sonera, or it could be triggered from a standard business tool like Microsoft Teams. You could interface with the agent here as though it's an employee in the organization, providing it context with what it needs to run. So it's saying it's done the setup, proceed with the simulation, yes, run the simulation. And then it will go away and actually run the simulation, and we'll get the results back in a moment. We can get the agent to publish those results into standard business tools as well. So the options are endless for how it can actually integrate. So that's an example of out of the box, how it works. But what if we then want to configure some agents? Well, we can go to our agent section here, and we can actually set up additional context for specific specialist agents in SimScale. So I have a Valve agent example here where we've got some instructions defined to the Valve agent, how we normally calculate the CV value of a valve. So let's have a look at this as an example of how an agent with additional context can work. So this is kind of the first level of customization for setting up an agent. So it's exactly the same workflow, but I go to run a new agent and I select the Valve agent from here. If I greet the agent has been pre-configured to give us all a greeting. So welcomes the attendees of the Future of Engineering Summit, and it gives us a quick joke. You can read the joke for yourself. I'm not going to read it out myself. So then we say we can take this to the next level and ask the agent to run our standard CV calculation. So now I don't need to provide anywhere near the same amount of context in the chat because it's pre-configured. It knows how we normally run a CV calculation for a valve. It knows our standard operating procedure. So it can just go straight ahead without having to ask us many questions back and set up that simulation for us. So it's now setting up the simulation tree structure, and it will go ahead and assign the fluid material and the boundary conditions needed for this simulation. So this is the first level of customization, and we're working with many organizations now to build much broader workflows, also engineering AI workflows that run from outside of SimScale, call the specialist agent to do simulation setups, analyze RFPs that are coming in, use an LLM to extract the requirements from that, and start to do the actual engineering work for us. All right. Just looking at the time, I'm just going to give it a few more seconds to do that assignment, and then I'll jump back to the final slide and give a quick summary. Here we go. It's doing boundary conditions, etc. You get the idea. So just as a final closing slide, this is an example of the sort of implementation that we're currently working on to take in those requirements and go through all of the necessary steps with exactly the sort of architecture, as Moritz was saying in Sonera, having an agent orchestration layer to control everything. All right, thank you.
Awesome, Stephen. Thank you so much. It's always doing a demo live while on Zoom is always a bit of a challenge, especially because I think somehow Zoom changes the way that the computer processes visually, and so it slows things down every single time. But I've always been impressed by SimScale. I feel like it's free preparation for machine learning every time you run a simulation. It's a great way to get things started. So we've heard now from the generative design side, the agentic AI side through Sonera, the PLM side through Michael, and the simulation angle through Stephen, and how that helps the training of AI.